The dignitaries have already arrived. The plenary session will commence shortly. The delegates are requested to kindly be seated. All the dignitaries have arrived. The delegates are requested to be seated, please. Ladies and gentlemen, a very good morning to all of you. May I take the privilege of inviting on the dais the chairperson of the session, Dr. S.K. Datta, Pro Vice Chancellor, Vishwabharati University, and the speaker of the plenary session, Dr. J.K. Ladha, renowned natural resource management scientist. Please, sir. May I now request Dr. Himanshu Pathak, Director, ICR NRRI, to introduce the chairperson of today's session. Please, sir.
That's what. Good morning, friends. I welcome all of you in the second day of our international symposium. I have been given a pleasant duty of introducing Professor Sapan Kumar Datta, but yesterday he has been introduced rather elaborately by Dr. Parida, who is the director of Institute of Life Sciences, Bhubaneswar. And after that, we had a very scintillating presentation, Rice and Politics. I don't know how much politics was there, but rice science was really covered, all history, present, and also future. So therefore, I am not going to introduce Dr. Datta again. But what I would tell about these two persons who are sitting on the dais in front of us today, I see them only in one way, that is, they are the mentors of many large number of scientists, whether in India or abroad. And let me tell you, both of them have been mentor for me also. I have been benefited from their guidance, from their suggestions for last so many years. I had the opportunity to work with Dr. Ladha in NRRI and also in NRRI India office, New Delhi, for many years. I think our relationship started in sometimes in 1994 or 95, and it continues till today, very actively, though of course not working together in one laboratory, though we work in different laboratories, but that doesn't stop our collaboration. Even last year also we had got one or two very important publications. So therefore it is really a pleasant duty and also a very privilege for me to welcome both of them in our institute. Welcome both of them on the second day of our international symposium. Sir, I thank you both, Dr. Datta and of course Dr. Ladha, to be here to grace this occasion and to encourage and guide our younger friends. Thank you very much. Thank you, sir. With this, I request Professor Datta to introduce our speaker today, Dr. J.K. Ladha. Sir.
Thank you, Dr. Himanshu, for such a nice, kind words. Good morning to everyone. It is really a pleasure for me to be with J.K. Ladha and to chair this session. Actually, I came to listen him long back. We didn't see each other and listen to each other's talk. J.K. is definitely a good friend and collaborator in all sense while I was working at AIRI. So long time we have been associated. We published paper together in Plant Journal and many other journals. So that means we not only friends, but we also collaborators in research, publication and research work. So it is again, it's a personal honor for me to say a few words about Dr. Ladha. He's a well-known soil scientist, not only in India, but throughout the world. He has made tremendous contribution in the field of agronomy and soil fertility, soil microbiology and plant nutrition. He has received many prestigious awards and honors, including Commission on Soil Biology for the International Society of Soil Sciences, 1992-2002, the CGIAR Chairman's Excellence Science Team Award 2000, the CGIAR King Bodium Team Award 2004, Outstanding Scientist Award by the American Association of Scientists of Indian Origin 2005, Frosty Hill Fellowship Award by the Council University 2007 and 8, Chair of the International Agronomy at the ASA for 2007-9, Plaque of Recognition by the President of American Society of Agronomy for Dedication and Services 2008, International Plant Nutrition Institute Science Award 2009, International Soil Science Award 2010, International Agronomy Science Award 2011, Lifetime Achievement Awards by the Soil Conservation Society, India 2014, International Crop Science Award 2015. JK, how long I should go on? It's quite a lot actually. It's a tremendous achievement. One could do it in this one life, and it's a continuous. I would just name a few and then stop. He is also elected Fellow of the American Society of Agronomy, Soil Science Society of American Association for the Advancement of Science, Crop Science Society of America, and the National Academy of Agriculture Sciences. As Dr. Himanshu mentioned that he is a mentor of many students and research scholars. I think at least more than 16 PhD students he supervised in his career, and probably associated with many number of students from India as well as from other countries. So the floor is yours, J.K. Ladha. Thank you. Give a claps to J.K.
Thank you, SK Swapan. SK is another Dedatta who is in Davis, a good friend of ours, and also good friend of Swapan. Can you hear me at the back? Okay, so it is quite overwhelming, and it's a really pleasure to be here. I thank Himanshu for giving this opportunity to share some of the work which we have been doing for last 30, 40, 30, 35 years. And the work which I'm going to share with you, some of that actually we did together. Himanshu, as he mentioned, we worked more than a decade together. And I think our working together has been very productive for both of us, and also hopefully for agriculture in general. I think yesterday was quite interesting, and to see the children performance. I was amazed to see how much talent these kids have. It was really enjoyable. So it was, I'm sure you are fully charged with the program we had yesterday. Let me thank the institute here as well as IRI for supporting my visit to this place and giving this opportunity. So some of the, and the title you see here, some of the changes which I'm going to discuss with you is not something started happening today or yesterday, but it has already been happening. But the rate of change will probably be much faster now in future, and there are changes which are yet to be coming. And what I'm going to share with you is of course my own experience and working with large number of scientists in India as well as globally. And I will mention in this particular slide a number of changes which I think likely to happen or started happening, and I'll give you the reasons why they will be happening. Soil puddling, this is a process, those who work on rice, they know it. I think we'll have to move away from soil puddling and move to no puddling or reduced tillage. And I'll explain what I mean by puddling, those who don't know soil puddling. And of course, labor and water are going to be important drivers. Transplanting, again, this is a century-old practice, and I think we have to move away from transplanting to drill seeding or machine transplanting. And again, I'll explain the reason. Continuous flooding. I mean, rice is grown with water all the time, and that's not going to be possible in future. So what I like to say, controlled water irrigation. 2 or 3 flooded rice crops. Not everywhere we grow 3 crops. Some we have also in Odisha, but in South Indian states, 3 crops, I think they will go away. And they will go away from 2 crops. One is wet season will still be monsoon crop, but the dry season will be some kind of aerobic crop because of water shortage. Inefficient carbon footprints, I think we'll have to go away and more climate smart practices. Hand weeding, which you know is a very, very drudgery involved, and it's a labor intensive process that has to go away, and already you see the signs of more herbicides coming in. So drudgery to more friendly machines and service providers, that's going to be culture in agriculture. Land fragmentation to more consolidation. I remember when I joined IRI in 1980s, economists used to talk about that, but what happened later on was just reverse. No consolidation, more fragmentation happened. But I think now there is a time that it's going to change. And the reason is the farmers are getting older. So elderly farmers and young farmers are coming, so more consolidation. Business as usual to more knowledge-driven and sensor-based agriculture. Hopefully from less profitable to more profitable, more diversification, value-added crops, hybrid crops, because farmers looking for more money for sure. And hopefully depressing farming to more attractive farming. So with this, okay, great. So with this background, I have structured my presentation as follows, but I think, Himanshu, I have to still show this one here. Yeah. So I'll talk about what is soil puddling and what is good and what is bad about it, and major drivers of shift, transplanting and soil puddling. Okay, we may say that it's not good, but what are the options? And go in little bit of options, what are the nut bolts, details of those. And I'll share with you some of the work which we have published together, and Himanshu mentioned about it. It came out in Nature paper also. And mixed model and meta-analysis for South Asia and global. and then move into plant selection, breeding for tillage and direct seeded rice. And I'll make a case that agronomists are ahead here than plant breeders in this particular case. And what are the threats and opportunities? There is no free lunch. If we propose something, there are always some downsides of that. And what are those downsides? We should be aware of that. And where we should be investing in future. And then hopefully we have some time for question answer. So what is puddling? You all know before rice is planted, we prepare soil and different ways you can prepare using carabao or the machines. It's a process of breaking soil aggregates into uniform mud by applying mechanical force to wet soils. And what it does, it decreases soil non-capillary porosity and corresponding increases in capillary porosity. Soil water retention markedly increases. Water percolation rates decreases markedly. So that's why you see soil, the water is standing all the time, and increases the storage of water in root zone. In addition to what puddling does actually, what good it does. In addition to those I mentioned already, there are other advantages as well. It controls weed by tillage and standing water. Enhances soil nutrient supply, especially phosphorus. Mineralization increases. And is easy transplanting of rice. I was really interested in knowing when this puddling kind of came in picture, and whether puddling came first or transplanting came first. And I couldn't find any reference except this 1920 publication, an Indian soil scientist working with a British soil scientist, and that time it used to be British soil directorate in India, and that's where first time they mentioned about puddling, 1920. Now let's move to transplanting. So immediately after soil is puddled, then you're transplanting your rice, right? And what it does, that you grow seedlings somewhere and then transplanting is done. Now why transplant rice? To ensure uniform plant stand. That's what you will see in the literature, and that's what everybody will tell you. And to give a head start over emerging weeds, because weeds also growing. So if you have rice which is already 2 weeks or 3 weeks old, you can suppress the weeds. And to establish, even if the field is not labeled and has variable water levels. But the question really is, and has been always in my mind, and I'm sure some of your mind as well, is it an essential practice? So what are the negative consequences of puddling? There's a large list. It requires more water, energy intensive, cracking of soils with loss of saturation, destruction of soil structure, which is negative for the succeeding crop, which is upland crop. Let's say in rice wheat system, wheat, or let's say rice maize system, maize of suffers, but rice system is okay. Longer turnaround time when you are doing puddling, and that's delaying the sowing of succeeding crop. And denitrification losses, when you have wetting, drying, you lose a lot of nitrogen, and decreases availability of soil P and dry season in succeeding dry season crops. So again, the question is, puddling essential? And I even saw this literature. Somebody said that is puddling a science or social? Because every farmer doing, that's why we have to do it. So there are shifts. There are drivers which are working to go away from puddling and transplanting. It's very labor intensive, 25% per day per hectare per crop, and timely available of labor, we know in India it's becoming a problem. The other one is very serious problem. It's all done by ladies, women. So the drudgery is involved. And then it's very intensive, energy intensive. You need 1500 megajoule energy per hectare per crop, and water of 40 centimeters on an average. Of course, it doesn't matter. All these are technical constraints. Farmers don't care about it. What farmers care is the cost, because puddling and transplanting alone take about 30% of total cost. So what are the options? And let me go through some details of what are the options we have. Puddling wet tillage, okay, you can avoid transplanting by direct seeding. And you can do direct seeding in soil. You can do direct seeding in dry soil using machine. And you can also do transplanting without manual transplanting by machine. Okay, so these are different options. There are many good machines available and they are coming from mostly Korea. And these are large transplanters which can work on puddled soil. If there is a requirement of some soil where puddling is essential, then it is possible. Unfortunately, these machines, very promising, but they have not been explored in South and Southeast Asia. It's still yet to be explored. Machine transplanting is becoming quite attractive in many parts of India, including India. Of course, many parts in the world, it has already been practiced. And this is something I think is going to be very important, especially in clay soils, where dry direct seeding, and I'll show you, is sometimes have difficulty. And there are different versions of these transplanters available: Japanese, Korean, and Chinese. Those who have worked in Tamil Nadu and Andhra Pradesh, it's becoming very popular. And these machine manufacturers, in fact, doing custom hiring. They are raising seedlings and they are transplanting. Very, very attractive model. So you don't run labor, and these machines are doing it, and custom hiring is happening. There is a good private sector involvement. What is important to make sure when you are doing machine transplanting, the seedling's health is good. And this is something you can do it by growing these seedlings in a special way in the trays. Now, what are other options of tillage and crop establishment? What I showed you is in wet soil, okay? And now dry soil. If you just don't want to do puddling, it's possible. You can have dry tillage. I don't recommend any tillage actually, because that's something is not good for energy, and also it's not good for you lose the carbon, soil carbon. But many farmers do that, and then manually they throw the seed, which is not very efficient. Just like think of you are on road and nobody follows the lane, the driving sense is not there. Nobody is following the lane, and they are going haphazard way, and it's a really chaotic. But you can use the drill and you can do seeding in rows. Other one is you can do without tillage, and again you do seeding with the drill. The other one is in between, strip tillage, which is kind of reduced tillage. You open the furrow, and then you either sow the seeds using drill, or you can even transplant. So what we call unpuddled transplanting. In some of the areas in Bangladesh, it's being practiced. Remember, puddling and transplanting can go everywhere once you fill the water. It's not site specific, but this is going to be very site specific and diversity of operations. And that's why farmers use different kind of machines which suit to them. We have been doing some very good work in Rice Wheat Consortium, and later on in Cereal System Initiative for South Asia, in India, with various partners. And there are these machines, and we worked with the machine manufacturers and agronomists working together and developing these machines. Not only it drops the seeds in rows, but also drops the fertilizer, so deep placement of fertilizer. And let me show you this, gradual evolution and improvement happen in the machines. Earlier, the seeds which these machines were picking up and dropping, there was a lot of breakage. So we changed it to incline plate or cup roll system, and now you can get very nice spacing of seed drop, and so nice establishment crop. And this has resulted into lower seed rate and prime seed rate. Seed can be also used, and very good establishment. What are the prerequisites when you want to move away from puddling and transplanting? So here are the agronomic prerequisites and also variety. You have to have good labeling, and I have put direct seeded rice on puddle soil, and other one is direct seeded rice on unpuddled soils. The red star shows that's where those are very important, and some of these like water management, weed management, and ability to do it with this residue, very important in unpuddled soil. But otherwise, some of those requirements are important for both conditions. When it comes to, so land leveling, good machine which can drop the seeds at right distance and right depth, seed rate, seeding depth, water management, weed management, ability to establish with residue, because we don't want to burn residue. Okay, and you know the story of what is happening in Haryana and Punjab, especially Punjab. And when it comes to variety, we need anaerobic germination and early vigor and lozing resistance. Land leveling, let me go some of the important requirements which we need for direct seeding and go one by one. One is land leveling. And these are the methods traditionally used for leveling land. Believe it or not, it's a very hard work. I mean, think of in small plots, farmers doing it, but when you have large plots, a lot of energy goes in there. So leisure land leveling, it becoming very, very popular and attractive. There are many benefits which are listed here. It reduces water requirement, improves crop establishment, and decreases time to complete task, increases the farming area by 5% because you remove the bunds. Better crop stands, increases yield, also lower weed pressure, and uniform crop maturity. I have never seen in my scientific career any technology going as fast as this one. It was in 2001 we introduced one machine. When Himanshu was still with us, we were working together. And we bought this machine, and then this number of machines multiplied. And this is not the machines which scientists or extension people running now. These are farmers. The progressive farmers are buying and doing custom hiring. And this is I have seen in some of the areas in UP, farmers running these machines to label the fields day and night. It's because it's just 2 or 3 weeks of windows and everybody wants to do labeling. There are so many advantages of land labeling. What land leveling does, and with the right machine which I showed you, we reduce the seed rate. In direct seeding, 100 kilos seeds are used, up to 100 kilos or more even. We reduce to 25 kilos with no yield difference, you see here. And that has got direct economic benefit to farmer. Water management is extremely important. There is no reason why you should flood the field. Rice, if you look at the ET, evapotranspiration is not very different from wheat. But we flood the field is just to avoid weeds and to avoid other things. Of course, it's a monsoon crop, but now water is in short supply. And I think we can live with what we call alternate wetting drying. Sometimes in farmers' field, it's already happening by default. And you probably know this pani pipe or a very simple tool of putting a small pipe in the field and seeing the water table and then deciding where to apply. But then there are a lot of good things happening in water management. These sensor-based technologies are coming in, which I think going to be very, very useful, not only for large farmers. Of course, to start with, it will be large farmers, but then small farmers also. And that's where I think water saving and efficiency will increase. I am very, very optimistic about this technology. I know most people you talk to, they don't think that drip irrigation can work in rice. But we have done work, preliminary work, 3 years. There are many logistical problems, but I think it has got a future. Some of the work which is done in Bisa farm in Ludhiana, and subsurface drip irrigation is very good, especially in zero tillage system, where you don't open the land and throughout the year. I think this is the technology for future. May not be today, but something I think we as a researcher should invest in there. Weed control is the #1 problem in direct seeding, and that's why farmers have not adopted it. And it's because when you go for direct seeding, when you don't puddle, the weed problems increases. And more weeds, higher cost, and greater yield losses. And integrated weed management has to be practiced, just like integrated nutrient management, integrated weed management. So you're getting this message that everything is going to be knowledge intensive as you move in new precision agriculture. So we have to use still weed seed bed technique, mulching, very, very useful. Instead of burning residue, put back on the field, and that helps in weed control. Use of suitable herbicides. We have to work with industries to develop new molecules of herbicides. Crop rotation, intercropping, hand weeding, and rice cultivars also, which are competitive to weeds, water management, and we got to worry also herbicide resistance of rice. Here some good work which we did in Cereal System Initiative for South Asia in phase 1. We used different molecules of herbicides, pre-emergence and post-emergence herbicide. And the red line which you see, the number of labor requires with different combination of herbicides. The last one where you see the weed-free, 94 labor is required. And if you do hand weeding, then 94 labor required. But we can reduce labor requirement without changing yield. If you use the first one, treatment 1, only 18 labors, and you have combination of pre and post-emergence herbicide. So we can control the weeds. Now let me move it to more towards the science part of this presentation. And I was mentioning about this mixed model and meta-analysis which we did for South Asia and also global. So South Asia data and actually quite a number of publications we already have. Dry direct seeding with residue mulch in crop rotation, and then we did global data set meta-analysis on farm and on station data, which we pulled together globally and analyzed using meta-analysis, new statistical techniques. And this paper just published Devashish Chakravarti, who works in NRRI, and it has come out in Nature Scientific Reports. So South Asia, we established 4 what we call research platforms, 3 in well-endowed areas in northwestern India, and 1 in eastern Indo-Gangetic plains in Bangladesh, and other one is more tropical south in Tamil Nadu. And we designed these the treatments or scenarios, what we call it, business as usual with farmer practice, where we have conventional tillage, crop establishment, then conservation agriculture, where we have zero tillage in drill shown with using drill in dry season crops only, in rotation with the wet season crop, and other one is conservation agriculture in all crops in rotation, and conservation agriculture in all crops with diversification. So very carefully designed, and we show in scenario 1 wheat after rice, which farmers follow, then wheat, mung bean, rice, so we put in mung bean there. The third scenario, wheat, mung bean, rice, and fourth one, wheat, mung bean, and rice was substituted by maize. And you see intensity of tillage, conventional tillage, which is intensive tillage, zero tillage, conventional tillage. And we had these combinations because farmers also have this mindset that rice, you cannot go away tillage, because we have been growing rice for so many years with tillage. And so we deliberately included those kind of components in order to show that it is possible that you can do either only conventional tillage in rice and zero tillage in wheat, or both zero tillage in wheat and rice. And we use this a comprehensive list of parameters to assess the system performance, not only grain yield, production of grain or calorie input, and that was done because we were working with different crops. So you can't just use the grain yield, even rice equivalent basis is not a good idea. So we converted it to energy. Economic returns, use efficiency of water, energy, fertilizer, labor, nutrient balance and soil health, ecological resilience, pest management, and also greenhouse gas emission and global warming potential. These are some of the results which you can see in these detailed publications. On the left side, it's on per unit area, on per hectare basis. On the right side, on per unit energy basis. So all the grain yield was converted to energy. And you can see here, the green one is business as usual scenario 1, and the red one is improved scenario, and there are large benefits in large number of parameters. This is very interesting piece of data. It shows relationship with the income, which farmers look at, and global warming potential. There is a negative relationship. People always used to say that if you are trying to save in too much, then it will not be ecologically beneficial or environmentally beneficial. And this data we showed that yes, you can achieve these two goals by reducing global warming potential, but still farmer can maintain the profits. So we concluded from here the high productivity with high input use efficiencies together with low global warming potential intensities with not conflicting goals and differential response of conservation agriculture in different land use patterns. And I didn't have time to tell you, but rice prefers to be more in lowland condition with puddling and transplanting. I'll explain why is that. And high economic returns possible with low GWPI. So now I move to my second part of the presentation, or data analysis. So we mined the data, global data, from 24 countries, 7 regions, 5 soil texture types, number of studies 370, number of tillage crop establishment option 6, and number of data points 4,600. And we analyzed the data meta-analysis. These are the treatments. So CT means conventional tillage, and TPR transplanted rice. That's a control, farmers use it. And then we have these different options. Conventional tillage direct seeded in wet condition, conventional tillage direct seeded in dry condition, reduced transplanted unpuddled transplanted rice, reduced tillage direct seeded rice, zero tillage direct seeded dry. Farmers modify these options based on how they can manage it. And you remember I told you this is going to be not site, this is going to be site specific and diversity in operations. So we had data of these treatments, and here are the results. And this is meta-analysis. All these treatments were compared against control, which is conventional tillage puddle transplanted rice. And we can see here the green numbers are number of data points, and the yellow numbers are difference from that control. So there was a yield reduction, significant yield reduction in whenever we reduced tillage and we moved from transplanted rice to drilled direct seeded rice. We also, when we separated the data, on station data and on-farm data, we found that on station has positive effect or less negative effect than farm data, and I'll explain what is of that. When you have good water control, which often is the case in dry season, then you in fact have positive grain yield with alternative tillage and crop establishment, and that really telling something. But more importantly, there may have been loss of yield, but look at, there is a saving of water, methane emission is lower, and cost is lower, and that income is higher. And that's why farmers would go for it. Now, why the yields are still low in zero tillage direct seeded condition. It's relatively new technology and recent introduction. Farmer is still not perfected. Think of puddling and transplanting farmers have been doing for at least decades, but this one is just maybe 1 or 2 decades old. Knowledge and tools driven, and variety is not bred for this condition. It's still our breeders breeding varieties for puddle transplanted conditions. But nevertheless, it is attractive because farmers get extra money and lower dependence on labor and mechanization and lower carbon footprint. So I think for us and also for farmers, it's quite attractive. What are the plant traits we need? And we analyzed this. We had quite a few brainstorming sessions with breeders and agronomists. Anaerobic seed germination, because when you are seeding and it is in the monsoon, rain can't come, and so you need anaerobic seed germination. High seedling vigor. In order to beat the weeds, it should grow quicker. And faster leaf area development. Strong, thick culm, because when you are direct seeding, then rooting is not that good. So you have to have strong culm. Tolerance to herbicide, because herbicide is going to be culture, is going to be important in direct seed rice. And nematode, some areas problem, and high genetic yield potential. So we have in NRRI a very strong program now. Thankfully, it came in late, but there is quite active program now. And all these traits which are important for direct seeding, they are looking at, biotechnologists are looking at, breeders are looking at. So I think we should have good material available few years down the road. Of course, there are always problems, as I mentioned. I'm towards my last few slides. And we should be aware of that. Direct seeding is not going to work wherever there is a variable rainfall pattern and availability of timely water supply. And that's why I always thought that it's to start with direct seeding, we should push aggressively in irrigated areas. Higher emission of nitrous oxide could be a problem because of wetting and drying. Some areas nematodes have been problem, but not where 2 crops of rice are grown. Evolution of new weeds, we have to be aware of that. And there are plenty we can learn from the countries where direct seeding is practiced. Vietnam, Sri Lanka, and those countries, and also US, for example, and how they have managed herbicide resistance. Higher dependence on herbicide, we should avoid that. Long-term sustainability, I think still we have to look into it. And something I like to advocate, and Himanshu, you should take lead here to design new generation of long-term experiments. ICR took leadership in 1960s and several long-term experiments all over India. And actually, interestingly, that was copied by other neighboring countries as well. And I think it's time now that we should review all those long-term experiments and take decision to stop some of those are not useful anymore, but think of new generation of long-term experiments. And I think ICR and this institute should take leadership. So, you know, often, sometimes donors ask these questions, oh, we give you $5 million, where will you invest? And this is what my list of land and environmental characterization. We cannot go on with direct seeding everywhere. So we have to have characterization and see where it's going to be, it's going to fit. Variety, irrigation management, herbicide, and new generation of herbicide molecules. Of course, nutrients, not so important, but secondary importance. Drills, which we already have good drills now available. And environmental footprint tax, which is something already happening in many developed countries. So the rice is coming in store and it gives the environmental footprint tag. And consumers picking up where there is less environmental footprint. And believe it or not, it's going to happen here also sooner or later. Maybe it will take 10 years or 20 years down the road, but it will happen. And long-term trials, again, I already mentioned about it. So we have global rice area, 158 million hectare, and rice area which is puddled is 125 million hectare, according to my best estimates. And if we do energy saving, labor saving, water saving, global warming production reduction, and net economic return, and if we multiply with 125 million hectares, huge benefit. Of course, it's not going to happen overnight. It's not going to happen 10, 20, 30 years, maybe not in our lifetime. But eventually, if we move towards that goal, I think, and it's doable goal. Scientifically, technically, it's feasible. So thank you, Sopan. You're the chairman.
You take some question? Okay. Thank you very much. We just heard a fascinating talk of an experienced person of 35 years on the subject and giving a talk like telling something is schoolboys type of lessons. The paddling, soil conservation, irrigation, mechanizations, weed management, herbicide use, paddling, where and how and why it should be continued, etc., as well as the economics of all the practices that farmers are doing today and what should be the future investment in this particular area. But the only thing he didn't say about organic farming. JK? One thing I did not hear from him, the organic farming anyway, this can be some sort of questions from the audience. As Dr. Latha mentioned in his talk itself that he would be happy to take a few questions or comments or sort of whatever you feel. So, so the floor is open to you. Yes, please.
Rice requires the leveled field. Wheat requires a graded field. What is your suggestion for rice wheat system?
So we can combine, the goals of both two, and not have tabletop leveling, but have slight slope, and that has already been worked out, which is good for both.
Questions here on the board.
Yeah, good question. And in fact, when I started my career, already people were talking about direct seeding. And I remember Dr. S.K. Dedatta, famous agronomist, rice agronomist, and he actually introduced direct seeding. And I could collect the data, Himanshu, when ERI long-term experiment started in 1960, there was direct seeding treatment there, which they discontinued after 30 years, unfortunately. So, everything has its own time. And sometimes if we have good science, okay, that helps, but that's not the everything. And that's not, I call it supply driven. Supply driven is when the factors like water and labor becoming serious problem. And that's where, farmers change, and farmers have no choice and they go. And I think it's time now, time is right now. And I think I have a strong feeling that direct seeding will move faster than it moved in last 20, 30 years. And it is already making headway.
Yes, thank you, Dr. Latha, for an excellent presentation. Among the other input for rice production, water plays a vital role. Somewhere we have mentioned that 40 centimeter of water is required.
Okay, that's for puddling. Puddling, initial puddling, 40 centimeter average required. Yeah.
In a traditional use, around 100 hectare centimeter water is required. And you told that alternate drying and heating. You see, can we enlighten at different stages, because sometimes alternate drying and whether how many days disappearance of the ponded water, it should be irrigated, because even if sometimes but in the real field when we used to see that there is a less of water, production is reduced, particularly when the crack develop.
Yeah.
So how to particularly in the say in the farmers field condition, how they will manage water.
Yeah. That's a very important and practical question of practical relevance. And often we scientists say that we tell farmers do alternate wetting drying, but how farmers is going to control that alternate wetting drying? He or she has to make sure that there is no over drying in process, because it's not only yield is reduced, but also we lose carbon. And of course we say that don't use too much water. And that's where, and some of these tools which are available, and pani pipe, you know, the pipe which you put in the field, and you see what is the water table, and then you apply water. And that's where more research is needed, and that's why I said water management is extremely important in direct seeding condition. Even though we claim that we have a good handle, but it's still a lot of work is required. And that's why drip irrigation, I'm very fascinated. Drip irrigation with fertigation. And that's something I think we should not be shying away in doing some of these high risk research, but with more impact, big impact. Yeah, Dr. Das. Yeah, please.
Yeah. Thank you, Professor Ladha, for this excellent lecture. We really enjoyed it. I have one submission and one question. So submission is that we fully agree with you that we should go for the direct seeding, and it has the many advantages over transplant as compared to your puddle transplanting. And my question for suppose the farmers, because they cannot go changing from transplanting to direct seeding very soon, especially for the income improvement as you're going for mechanizations, we have a difficulty using transplanter for the puddle transplanting. Because the transplanter we are using in Indian conditions, because we are not able to control the water, and we have to use the small seedling, maybe 10 centimeter. So the moment you are transplanting, on the very next day, if there's a heavy downpour, so entire field gets washed away. So how our scientific community can, because farmers need a good transplant for Indian conditions. Yeah. How can you do that one? Yeah.
Again, good question, and I think you yourself answering the question probably, and that is, you should go to areas where these constraints are less. You go to irrigated areas where there is a good water control to start with. I mean, if you can cover whole Punjab, Haryana, Western UP, and some of the states in South Asia, already happening, South India in fact, puddle transplanting and mechanical transplanting. I think that will be a big game changer.
Two questions.
Yeah.
Cost effective in terms of conservation.
Yeah, how to take them end users. Again, that's where our infrastructure, extension infrastructure has to be very, very strong. And that's something, has to be improved. I think, we have done good research, but we are not as good as in moving these technologies and practices to farmers, and the delivery has to be improved. And I think private sector should be involved probably if you want to see successful models, what is happening in other countries. So that's one way to do, one way to go. Yeah. Yeah. So anaerobic germination, I don't know what is the question about that. I'm not familiar. I think hydrogen, there is one chemical used when there is a variety does not have anaerobic germination. I don't know exactly, I don't remember, but I think it's going to be useful if we have varieties with anaerobic germination potential.
Direct seeding is always being supplemented by the application of weedicides. But we have seen that even 2,4-D application that induces polygenic mutations, and the weedicides used, have they any effect in deteriorating the genetic purity of a variety?
Yeah, anytime you use any chemical, it's just like antibiotic resistance. When we take antibiotic, we got to make sure we are not overusing it. And we are not using same antibiotic again and again. Otherwise, you develop antibiotic resistance. And so herbicide is no different story. And 240 is now banned, actually. It's not used. But now, and that's where I said, we as a scientist have to work with industries, those who are producing herbicide molecules, and make sure, and this is something we can learn from. Those mistakes happened in other countries, and in advanced countries, and also some of the Sri Lanka and Vietnam. So we can learn it, and we can beat herbicide problem. US has successfully done it.
Your opinion on drip irrigation, drip irrigation for direct seeding?
Yeah, I already mentioned about it, and I'm really fan of drip irrigation. Yeah.
Last question. Okay.
Yeah.
Dr. Laza, you had a very excellent presentation on management, land management, water management, whatnot, crop management and all that. I will simply supplement something. The experiences that we have in CRI, Cuttack, NRRI, there are two situations where direct seeding is practiced and also are important. One is the upland, the other one is the rain-fed lowland. Okay. I conducted experiments for several years, maybe more than 10 years in rain-fed lowland rice, where simply by placing the fertilizer in the in furrows, and then sowing the seed in the same furrow, and then covering the furrow by this alternate furrow, means next furrow, while farmer has a small plow, and then that can be sown. That gives more than 2 tons higher yield than the normal broadcasting or transplanting after 15th of July. That means this practice has to be started by 15th of May in Eastern India, I am telling, from 15th of May to 15th of June, not June also, 31st of May. During those 15 days, the direct seeding has to be completed. But only thing is that soil tillage. If the soil tillage is not favorable for direct seeding, especially with the machines, then that creates problem. So for that, immediately after the December harvest of rice, we open the land so that there is and then we open the land with the 2 plowings, and then we leave it for rain to occur, summer rain to occur. With summer rain, the clods crumble, and then the rain-fed lowland soil, which is about clay, 40% clay, that works as if a sandy soil while running the soil tillage equipment, means and then sowing equipment, both fertilizer, seed, and then both put together in drills. That is one of the best answers for this rain-fed lowland rice. And in case of plant, also by Roja, means this what we call this 15th of June, that sowing before that date only, before 15th of June, direct seeding is to be done. So this is about the climate, soil, and then soil tillage, and then this I wanted to supplement only, but not a question. It's not a question.
No, thank you. Thank you very much for sharing. I mean, that is something your experience, and you're very right, and I agree 100%. There is a window in rain-fed condition. There is a window. We should take advantage of that window. If you delay it, then you are killed. Then rain comes. And what you said, fertilizer, deep placement, and seeding, and I think machines can do a better job than farmers will do by hand. So thank you for sharing.
Is also not affected by the furrow placement of fertilizer as well as what that I have seen. Maximum 10% damage may be there in germination. That is compensated by increasing the seed rate by 10%. Okay, thank you. Thank you.
Thank you, JK, for an excellent presentation as well as interaction from the audience. Give a big hands to JK.
Thank you, sir. May I now request Dr. Himanshu Pathak to kindly felicitate the chairperson of the session. May I also request Dr. Pathak to felicitate the speaker of the session. Thank you, sir. As we conclude the plenary session, I, on behalf of ICR NRRI and Association of Rights Research Workers, convey my sincere thanks to the chairperson and the speaker of today's session. I would also like to thank the rapporteurs of the session, Dr. Pratap Bhattacharya and Dr. Shushmita Munda. I would also take the opportunity to thank the audience for their attention and patient hearing. The dignitaries are invited for planting of saplings near the new genomics lab. So, sir, you are kindly requested to proceed for the planting of saplings. Thank you. Ladies and gentlemen, the technical sessions will commence shortly. There will be 2 parallel sessions. The session on efficient resource utilization and system analysis will take place in the main pandal. The session on molecular interventions for trait improvement will take place in the conference hall. The participants are requested to deposit their slides at the technical counter near the dais. Thank you. The delegates are also requested to access in slido.com #ARRW2018 to post their questions. Thank you.